Today, we will be reviewing the process of microarray-based genotyping, as well as its uses by companies such as 23andMe and its points of ethical concern. So what is microarray-based genotyping? Microarray-based genotyping is a genetic tool used to determine if an individual has a mutation caused by a single nucleotide polymorphism, also called a SNP. Some important things to note. Firstly, the process involves the use of a chip, which is often a glass plate encased in plastic. During the actual genotyping process, the chip will contain thousands of short, synthetic, and single-stranded DNA sequences, or single-stranded oligos. Also, the test ultimately detects known variants in the gene of interest. So now we are going to go over the actual genotyping process. First, let's review what allele-specific oligonucleotides, or ASOs, are. ASOs are short oligonucleotides that are used as probes for the target DNA, and they are attached to the chip during genotyping. The ASOs will eventually be hybridized with the genomic DNA of interest. This hybrid will be more stable at higher temperatures if there is complete complementarity between the ASO and the genomic DNA. The hybrid will be less stable at higher temperatures if there are mismatches. This is because there will be less hydrogen bonds holding the probe and target together, and less heat will be required to detach the two. Now let's discuss how we will actually obtain this target genomic DNA. First, the DNA will be cut or fragmented using restriction enzymes. Adapters will then be ligated to the fragment, which will allow the DNA to then be amplified via PCR, or polymerase chain reaction. The fragment is then denatured to separate the double strands and create a single-stranded product. Finally, a fluorescent dye is added to an end of the single-stranded DNA product. This final product will later be added to the same chip. So how do we analyze the results of microarray-based genotyping? So we have our chip with the single-stranded oligos for different SNP alleles. Our fluorescently tagged genomic DNA is then also incorporated onto the same chip. Fragments with perfect complementarity will hybridize to the matching part of the chip. Now we can take a look at the fluorescence. The amount of fluorescence distinguishes whether the genomic DNA is homozygous or heterozygous for a certain SNP. More fluorescence indicates a homozygote, whereas less fluorescence is indicative of a heterozygote. This technology is the same used by the company 23andMe, which is most commonly known for its ancestry DNA tests. Kits are purchased online and purchasers send back their saliva. The company offers a variety of tests such as ancestry analysis and variant detection for health conditions or traits. The health condition tests can detect diseases such as celiac disease, a predisposition of type 2 diabetes, and also the carrier status for autosomal recessive diseases like sickle cell anemia and cystic fibrosis. Test results take up to 3 to 4 weeks to receive via email, and test results include variants not detected, variants detected, and results not determined.
Now we have a little more on reports, and more specifically risk reports. Some reports are optional to receive as they can contain information about serious diseases that don't currently have a cure or an effective treatment. Although not required, purchasers who choose to receive these results will be encouraged to meet with a genetic counselor. Also, knowing about genetic risks can impact one's ability to qualify for some insurances, which we'll cover more on that later. Two of the major risk reports can include cancer risks and risks of Alzheimer's disease development. The cancer risk report is determined by the BRCA1 and BRCA2 variants. For females, a variant being detected indicates a 45 to 85% chance of developing breast cancer, as well as a 46% chance of developing ovarian cancer by age 70. For males with detected variants, there's up to an 8% chance of developing male breast cancer, and individuals may have a greater risk of developing prostate cancer. For both males and females, a detected variant correlates to an overall risk in developing pancreatic cancer and other cancers. Another major risk report has to do with the developing of late-onset Alzheimer's disease. The test reports on variants in the E4 variant of the APOE gene, which is associated with an increased risk of developing the disease. Currently, any testing for the E4 APOE gene variant isn't recommended by any healthcare professionals or providers. This leads us into our discussion of the ethical concerns behind these types of genetic services. 23andMe allows those who purchase their kits to omit certain test results, including those for BRCA1 and BRCA2 variants for cancer development, variants for hereditary prostate cancer, the E4-APOE gene variant associated with Alzheimer's disease, variants for Parkinson's disease, and those for MUTYH-associated polyposis, a condition that leads to a polyp growth. Polyps are growths that can turn into cancer if not removed. Whether one chooses to receive these results or not, 23andMe provides genetic counselors to go over any test results received. 23andMe also warns that receiving information about genetic risks can affect one's ability to obtain some types of insurances. The 2008 Genetic Information Non-Discrimination Act, or GINA, protects Americans from discrimination based on genetic information by insurance companies and employers. However, according to Forbes Advisor, GINA protections do not extend to life insurance, disability insurance, or long-term care insurance. So there is no federal law that limits the use of genetic information by life insurance companies. Whether the ethical concerns stem from insurance policies or the availability of genetic testing is still an ongoing debate today. More recently, actor Chris Hemsworth of Thor took a DNA test as part of a production. According to a New York Times article, Hemsworth learned that he did in fact have 2 copies of APOE4, and has since decided to take a break from acting to spend time with family. As genetic tests are becoming a more common product, more people are discovering that they have these variants for incurable diseases or conditions with ineffective or risky treatment options. However, these same tests also allow people to determine their career status for such diseases, as well as connect with their ancestry, which can be especially gratifying for adopted individuals. Mainstreaming these genetic services certainly has its ethical issues, but these controversial aspects can certainly be avoided with measures such as the exclusionary options offered by 23andMe.